Section 5.3, Sum and Difference Identities. Problem 2 is find the tangent of 15 degrees exactly by using sum or difference angles. While this problem looks simple, it turns out not to be as simple as it looks. Recall, we know exact identities for 2 pi, 180 degrees, 90 degrees, 60 degrees, 45 degrees, 30 degrees. Tangent of 15 degrees would be the difference between 45 degrees and 30 degrees. Using our tangent identity, we know that this is equal to the tangent of 45 degrees minus the tangent of 30 degrees over 1, and then we change the sign or reverse the sign, 1 plus the tangent of 45 degrees times the tangent of 30 degrees. Recall our triangles. A 45 degree angle has 1, 1, square root of 2. A 30 degree angle has 1, 2, square root of 3. The tangent of 45 degrees is 1 over 1 minus the tangent of 30, which is 1 over the square root of 3. And then on the denominator, 1 plus 1 times 1 over the square root of 3. Anytime we have a quantity like 1 over the square root of 3, we can multiply that by unity, the square root of 3 over the square root of 3, and that will give us the square root of 3 over 3, and eliminate the radical in the denominator. So let's do that. So we have 1 minus the square root of 3 over 3, 1 plus the square root of 3 over 3. Now let's multiply by 3 in the numerator, 3 in the denominator, which would just be unity. And we have 3 minus the square root of 3 over 3 plus the square root of 3. Repeating what we had on the previous page, to eliminate what is in the denominator, we need to multiply by 3 minus the square root of 3. Take the radical part and put a negative sign in front of it. And in order to do that, we can multiply by unity, so we'll multiply by 3 minus the square root of 3 over 3 minus the square root of 3. In the denominator, we get 9 minus 3. In the numerator, we get 3 minus the square root of 3 squared. Denominator is equal to 9 minus 3 is 6. The numerator is equal to 9 minus 6 square root of 3 plus 3. Looking at the numerator, we have 9 plus 3 is 12 minus 6 square root of 3 over 6, which reduces to 2 minus the square root of 3. This is our exact solution, but as I said, it is a little more difficult than it looked like in the beginning. In problem number 8, we desire to find the exact value of the tangent of 11 pi over 12. (11 pi over 12 is this angle here, which would be 15 degrees. If we look at that as one of the angles we know, 90 degrees, 60 degrees, 45 degrees, 30 degrees, we see that this is equal to the tangent of 120 degrees, 2 pi over 3, plus 45 degrees, pi over 4. From our trig identity, we know this tangent of 2 pi over 3 plus pi over 4 is equal to the tangent of 2 pi over 3 plus the tangent of pi over 4 over 1 minus the tangent 2 pi over 3 times the tangent of pi over 4. Now, recall 2 pi over 3 is 120 degrees. It's a triangle that looks like this. The sides are 1, 2, and the square root of 3. Pi over 4 is a 45 degree angle with sides 1, 1, square root of 2. So the tangent of 2 pi over 3 is the square root of 3 over minus 1 plus 1 over 1. And on bottom we have 1 minus square root of 3 over 1 times 1. That gives us the minus the square root of 3 plus 1 over 1 plus the square root of 3. To get rid of the radical on the bottom, we need to multiply by 1 minus the square root of 3, so we have to multiply the entire quantity by unity so that we make no change in the identity. So we multiply by 1 minus the square root of 3 over 1 minus the square root of 3. Then in the denominator we have 1 minus 3. In the numerator we have 1 minus the square root of 3 squared. This is equal to minus 2 in the denominator, and on top we have 1 minus 2 square root of 3 plus 3. 1 plus 3 is 4, minus 2 square root of 3 over minus 2, and our answer turns out to be minus 2 plus the square root of 3. In problem 27, we want to prove that the sine of x plus pi over 6 is equal to the square root of 2 times the sine over 2 times the sine of x plus 1/2 cosine x. Let's expand sine of x plus pi over 6 by the formula that we know. This will be the sine of the first term times the cosine of the second one. We keep the same SIG in, but we reverse sine and cosine. And this is the left-hand side. So let's take and put the cosine pi over 6 in front of sine x so it looks like the right-hand side over here. Sine of pi over 6 times the cosine of x. Let's look at the angle again, pi over 6, which is 30 degrees. We know that that's 1, 2, square root of 3. The cosine of pi over 6 is the square root of 3 over 2. The sine of pi over 6 is 1 over 2, 1/2. And we have what we desired to show the identity. In problem 41, we want to prove that the cosecant of pi half minus u is equal to the secant of u. Let's break the cosecant down into its basic definition. This is 1 over the sine pi halves minus u. Let's just take the left-hand side. So I have 1 over the sine of pi halves minus u. This is equal to 1 over the sine pi halves cosine u minus the cosine of pi halves sine u. If we remember the functions, the cosine looks like this. The cosine of pi halves is 0. The sine function looks like this. The sine of pi half is 1, so this is 1 over 1 times the cosine of u minus 0 equal 1 over the cosine of u, equal to the secant of u which we desire to prove.